Good afternoon, my dear students. How are you all? Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. I am Suresh, Faculty of Chemistry. How are you all doing? Great to see that you are online. Very good. Abhinav Mohanty. Yes. Yes. Good afternoon. Can you please confirm, am I audible and you can see me? Great to see that you guys. Very good. So, welcome to NEET STEP UP 2025 program, and in this program we are offering on YouTube platform physics, chemistry and biology session right from 12 o'clock to evening 6 o'clock. And these sessions we are giving at the level of NEET examination. You just make use of this session by attending regularly and following the progress and the program that given by the eminent faculties on YouTube channel by Infinity Learn. So, if you do so, you will be getting a very good score on NEET examination that you are going to write in 2025 program. And these sessions are absolutely useful for those who are studying in 12th and 11th and who dropped from 12th standard and preparing for, take a drop and preparing for NEET 2025. Are you ready? So today's agenda is going to be thermodynamics. The overall revision right from thermodynamics first law till thermochemistry Hess law. So we are going to from first law to Hess law. Are you ready? Yes. कोई problem नहीं. Arfat Khan, the thermodynamics concept is common for both NEET as well as an IT. So not an issue. You can join with that. Okay. How the things are going on? Anubhav Mohanty and Arfat Khan. How the things are going on? Just give reply. Can you able to see me? Can you able to hear me? Okay, so still waiting for those students, Ishita, Richa Sharma, Annamani, Abhinav and many students, Shivans, many students had to come. Those students, I still remember every student name and their presence, their responses and everything. So you also be regular in the sessions so that I can just track your performance, because while we are doing the questions on the slides, the same questions, the way the students are giving answers, I am tracking. So it is an interactive session on YouTube channel, my dear students. So आज हम क्या करने वाला है, क्या चर्चा करना है ना? So get ready with that. So आज का क्लास में हम देखना चाहता हूँ, yes, what you are going to learn. It is first recapture of the first law of thermodynamics and talking about entropy, second law of thermodynamics, Gibbs free energy and spontaneity, thermodynamic equations along with Hess law and many more things along with questions. Are you ready? Are you ready? So without any delay we can start the session. So give one thumbs up and fire emoji to start the class. So these topics that are absolutely important for your competitive examination. So in the NEET examination you can get, definitely you can expect a question based on, among all topics you can see criteria of spontaneity on Gibbs free energy and also thermochemical equations and Hess law. And moreover, first law of thermodynamics also we already completed. We had a couple of sessions based on that. Ready? That's good. So ये टॉपिक से आपका कम से कम एक क्वेश्चन thermodynamics सीधा आने वाला है, and related to the criteria of spontaneity it is connected with the other topics, and you can get one more question there itself. Delta G कब positive होता है, delta G कब negative होता है, and delta G equilibrium भी connected है पर, right? So why late? If you have any doubts, you just use your chat box and engage yourself by using chat box, and we can make the entire session for the next 90 minutes with a lot of fires and enthusiasm, right? Dear students, why late? We just start about the first law of thermodynamics. So we'll see thermochemical calculations करने के बाद at the end we are going to see the thermochemical calculations with Hess law and first law of thermodynamics. This first law of thermodynamics is based on the energy conservation. It says energy neither be created nor be destroyed, rather it can be changed from one state to another state. So I want to say, if some quantity of energy is disappeared, some quantity of some energy is disappeared, the same quantity of another form of energy should appear, so that this energy is conserved. Or otherwise, if some quantity of energy is disappeared, the same quantity of work should be done. So this is according to the first law of thermodynamics. So in any process, the sum of energies of the system and surrounding is constant, the total energy is conserved in a given process. And you can say first law of thermodynamics rules out the existence of a perpetual motion machine of the first kind. Yes, good afternoon, Anamani. And also we can say first law of thermodynamics is known as law of conservation of energy, and the mathematical form of first law of thermodynamics is delta U is equal to Q plus W. We are going to see this is a system. मान लो ये सिस्टम का पहले जो एनर्जी इंटरनल एनर्जी U1 है, एंड अगर आप कुछ Q हीट बना दो अंदर घुसना, एंड ऑल्सो यू जस्ट डू सम वर्क ऑन इट, सो दैट इसका वजह से इंटरनल एनर्जी ऑफ द सिस्टम U2 तक बदला है. सो दैट U2 मान लो ये किस किस का इक्वेट एनर्जी कंजर्वेशन के हिसाब से U1 प्लस Q प्लस WB है. यस, यू कैन से दिस इज U1 इस तरफ लेके आओ, सो दैट U2 माइनस U1 इज इक्वल टू Q प्लस W. So U2 minus U1 is equal to change in internal energy delta U is equal to Q plus or minus W. So this is what you call it as mathematical version of the first law of thermodynamics. In this first law of thermodynamics W can be negative or positive. So the sign conversion, if work done by the system is going to be negative, work done on the system is going to be positive. We will see this in various processes also. Now we can see heat absorbed by the system of work done on the system is negative. Dear students, here the reverse, heat given by the system or work done by the system is going to be negative. And if heat is absorbed by the system and work done by the system, W is negative, Q is positive. So change in internal energy is going to be Q minus W. So you just see, when you solve a numerical, you just follow this statement and you can apply this equation. Are you getting or not? Clear? That's good. And if the heat is absorbed, ये उल्टा होगा. If heat is absorbed by the system and the work is done by the system, delta U is equal to Q plus W. है ना? So W is positive in this case, W is negative in that case. Yes, Arfan, right? So good. Hope you understand. Any doubts, Anamani, Abhinav Mohanty and Arfat Khan? Any more students there who are not active in the chat box? Come on. Great to see. And और कुछ चीज़ है, IUPAC conventions are important. IUPAC conventions are important. In this IUPAC, heat liberated by the system and work is done by the system, that is going to be Q minus होगा and WB minus होगा, plus or minus. If you want to say in the chat box, use plus or minus, है ना? Right. And heat is liberated by the system and work is done on the system, Q is going to be minus and work is going to be plus. Now heat change in a system can be taken place at constant volume and constant pressure. There are two things. Ishita, you can see in this first statement, this is a system. In this system, heat is liberated, Q is going to be minus, and work is done by the system, so that W is going to be minus. Whereas in this second one, heat is liberated by the system, Q is going to be minus, and work is done on the system, W is going to be plus, right? That's it, Ishita. So you just always understand system को फायदा उठ रहा है, जो भी चीज है प्लस है. So system loses something, it could be done by the system or heat is lost by the system, is going to be negative. That is a simple negative and a positive makes this particular first law of thermodynamics as a key point. This is the key point. So when you know delta U is equal to Q plus or minus W, so when you do the numerical entirely, it is correct. But if you say multiple choice question A, B, C, D options, just the same answer what you got will be displayed with different minus and plus. You need to get a correct sign conversion. So this slide can tell you the actual answer kaisa pakadna hai na beta? Clear? Ishita, fine? That's good. Now let's go ahead. IUPAC conventions mein, if the process is carried out at a constant volume, so there is no volume change is done, so there is no mechanical work is done. So इस समय में delta V is going to be 0. Work done, PV work done के हिसाब से work done is equal to minus P external delta V. So W is going to be 0 यहाँ पर, right? क्योंकि change in the volume 0 होगा and work done 0 भी है, okay? And one more thing, from first law, the constant pressure, if the work done is pressure volume work, then work will be denoted by PdV, that's we know, and therefore from the first law, U2 minus U1 is equal to delta U is equal to QP minus P delta V. So that is going to be given like this. QP is the heat absorbed at constant pressure, right? Heat absorbed at constant pressure. So this is the like a fiery fly of the thermodynamics total revision. So whatever I am currently discussing is already discussed in the yesterday and day before yesterday's class. It's just a recapture, because this kind of recaptures are very important for doing thermodynamics. So why thermodynamics? You are doing a concept 1, concept 2 and concept 3. जब आप concept 3 पकड़ रहे हैं ना, concept 1 का confusion निकल रहा है. So इसका कैसे उठाना है? So you have to just go through the quick revision and एक cheat sheet भी बनाना है आपका preparation में. आप जो जैसे अभ्यास कर रहे हो ना, वैसे आप examination में लिखना, so that the teacher given some guidelines, you follow those, and those guidelines give you the excellent score and you will be the topper in NEET examination. Ready? Fine? Yes. So I request my dear students, you all just join these sessions every day, that is the first point, and like the session and share with your friends and subscribe to the YouTube channel of Infinity Learn by Sri Chaitanya, right? And एक बेल आइकन दिया ना ये वीडियो में, ये दबाओ एक बार, आपको नोटिफिकेशंस आते रहते हैं, है ना? कब क्लास होगा, कैसे होगा, सब मिलेगा आपको. नेक्स्ट, IUPAC convention, U plus PV is called enthalpy, denoted by H. Enthalpy means Greek, it is warm in. So actually what is this enthalpy? Enthalpy is a thermodynamic term which talks about the heat content at constant pressure. Why we need this thermodynamic parameter of enthalpy? Because सारे के सारे all chemical reactions that is happening around us on the chemical laboratory, even they are going against to the external atmospheric pressure. So that is a constant pressure work. So ये constant pressure heat calculate करना के लिए आप enthalpy निकालना है. So enthalpy is nothing but H is equal to internal energy plus some work, that is PV work. So that we just see H is equal to U plus work is given as P delta V. Simple. अरे इतना simple है thermodynamics सीखना. If you go into the mathematics and physics, you are going to just घुमा घुमा के कहाँ जा रहे हैं आपको भी पता नहीं. Okay, so H is equal to U plus PV, and since Q minus H2 minus H1 is equal to delta H, since QP is equal to H2 minus H1 is equal to delta H, where U is internal energy, P is the pressure, and V is the volume or state function. So the state function is the thermodynamic property which depend on the initial and final state, but not on the path of the process. So here H is also a state function, so that we can say delta H is equal to delta U plus P delta V. P delta V, PV is equal to nRT का हिसाब से, PV is equal to nRT का हिसाब से, P delta V is equal to delta nRT. R is a constant, T is a constant. At constant pressure, P is a constant. So that you can say P delta V is equal to delta nRT. यहाँ पर delta n होता है क्या? Who is going to tell? इशिता जल्दी बोलो, ये डेल्टा एन क्या किस चीज का है? ये डेल्टा एन किस चीज का है? That's it, change in the number of moles during a chemical reactions that I want to show you. Delta H is equal to delta U plus delta nRT जी है ना. So number of moles of gases, the change in the number of moles of the gases. Yes, या माफ कर दीजिए, हाँ माफ कर लेता हूँ. You are 20 minutes late. You are 20 minutes late, Abhinav. Okay, so every day you come join on time, Abhinav. राइट now लगे रहो चैट बॉक्स में. सो आपका ये डेल्टा एन जो है ना, ये काफ़ी इंपॉर्टेंट है. सम ऑफ द नंबर ऑफ गैसेस प्रोडक्ट्स माइनस सम ऑफ द नंबर ऑफ गैसेस रिएक्टेंट्स, इट्स ओके. सो सम ऑफ द नंबर ऑफ गैसेस प्रोडक्ट्स एंड सम ऑफ द नंबर ऑफ गैसेस रिएक्टेंट्स, वी आर गोइंग टू सी दैट. सो इन दैट यू कैन से केस वन. केस वन ये किस केस का है? सो delta H is equal to delta U plus delta nRT. So we are going to apply this in different cases. Yes, Ishita. अगर डेल्टा n इज इक्वल टू 0, ये डेल्टा n क्या चीज है अब भी आपको सिखा में. डेल्टा n इज इक्वल टू सम ऑफ द नंबर ऑफ गैसेस प्रोडक्ट्स माइनस सम ऑफ द नंबर ऑफ गैसेस रिएक्टेंट्स. सिर्फ गैसेस को पकड़ना है, शुड बी इन द गैसेस, अदरवाइज यू शुडंट टेक द वैल्यू, है ना. राइट, नाउ इन दिस केस इफ डेल्टा n इज इक्वल टू 0, एग्जाम्पल मान लो H2 इज अ गैस एंड I2 इज अ गैस गिव्स राइज टू HI इज अ गैस. उसमें आपका डेल्टा n इज इक्वल टू प्रोडक्ट्स कितना है, ये प्रोडक्ट्स है 2 माइनस यहाँ पे 1 है, यहाँ पे 1 है, सो दैट 1 प्लस 1 है इज इक्वल टू 0. सो अगर ये वैल्यू 0 मान लो, डेल्टा H इज इक्वल टू डेल्टा U, दैट इज द केस 1. अंडरस्टैंड? क्लियर? यस, प्रोडक्ट्स माइनस रिएक्टेंट्स, दैट्स गुड. सो यू नीड टू जस्ट provoke the entire class ambience by taking the appropriate answers and appropriate responses in the chat box, है ना. Right, that's good. So this is the way we enjoying in the class, right? है ये ना. Now और case 2 है, अगर if delta n greater than 0, किस रिएक्शन में डेल्टा n greater than 0 आ सकते हैं? So again I just want to give you one more example. Example मान लो PCl5 which is in the gaseous state and on decomposition gives rise PCl3 in the gaseous state and Cl2 in the gaseous state. So delta n आप कैलकुलेट करना की कोशिश करो, इसका डेल्टा n आपका आना है. सो यहाँ पर एक नंबर 1 प्लस 1, यहाँ पर एक नंबर है -1, सो इट इज गोइंग टू बी +1. डेल्टा n +1 है. So that delta H is equal to delta U plus 1 RT. So that 1 into RT. So delta H इससे greater than होगा. That is the case 2. That is the case 2. And one more case 3 का है. अगर डेल्टा एन नेगेटिव, किस रिएक्शन में नेगेटिव आ सकता है? मान लो आपका हेबर्स प्रोसेस है, N2 is a gas and H2 is a gas. ये रिएक्शन gives rise ammonia is a gas. ये बैलेंस है? नहीं है. सो मैं क्या लिखना चाहता हूँ? 3 and 2 and 1 है ना? 3 and 2 and 1. सो दैट इसका डेल्टा एन कितना होगा अभिनव? Log of item is there in the class today. Okay, it is going to be 2 minus 1 plus 3 is equal to how much? Minus 2. So that it is going to be delta H is equal to delta U plus minus 2 RT. So that delta H is less than delta U. Case 3, case 2 and case 1 का है. So this is the simplest analysis of the thermodynamics enthalpy and internal energy relation. Happy? Hope you understood, Ishita? Yes. Good. Now let's see the more applications of this. exothermic reactions हो सकते हैं, endothermic reactions हो सकते हैं delta H का हिसाब से. So let's types of reactions. We have exothermic reaction, heat is released, exothermic heat is released, heat released, so that delta H is going to be negative मान लो. And endothermic reactions, heat absorbed, so that delta H आपका मिलेगा positive होगा. Right, it is. Right, it is. Any lag? Can you able to see me? Can you able to hear me? Just give a confirmation. Ishita, make it fast. Can you able to hear me? हाँ, करेंगे? Yes, it is. Now let's talk about, we are entering into the second law of thermodynamics. In the second law of thermodynamics, let's talk about the entropy. So what is entropy? What is entropy? So when you go and see in the school assembly in the morning, in the presence of headmaster, the principal, all the students are organized. So the system has molecules of the particles inside it, right? So they are organized. Now when the system is disorganized, जब disperse बोलते हैं ना आपका students, so they are going to move like this, so that more random, more organized. System का organization जो important है. So this is what is called organized, disorganized, or disorganized, or disorganized. So कितना disorganized, इतना random है ना उसमें. So यहाँ पर randomness ज़्यादा है, यहाँ पर randomness कम है. So a randomness measure करने के लिए thermodynamics में एक thermodynamic property दिया, that is entropy. So high randomness, high entropy, high disorder. Disorder means randomness. So low randomness and low entropy and low disorder. So entropy is a thermodynamic parameter which measures the degree of disorder or degree of randomness. So based on that we are going to enter into the second law of thermodynamics. So you can see what is entropy. It's a measurement of degree of randomness of energy of a system, है ना? So the lower the entropy, more order, and less is the randomness, and it is vice versa. And high entropy, low entropy. So low entropy means low randomness and more organized. It is more organized, right? So you can have various discussions about entropy is a measurement of disorderness or randomness of a system. It is denoted by S. So you can't measure the absolute value of entropy, rather you can measure the change in the entropy. And entropy is a state function and it is an extensive property. Thermodynamics में जैसा क्वेश्चंस आता है ना, which of the following is an extensive property, which of the following is an intensive property, ऐसे क्वेश्चंस आते रहते हैं. सो ख्याल में रखो बेटा, एक्सटेंसिव प्रॉपर्टीज एंड इंटेंसिव प्रॉपर्टीज याद है, एंड स्टेट फंक्शंस एंड पाथ फंक्शंस. And entropy of a substance is the lowest in its crystalline state and highest in its gaseous state. That's what we have shown in the previous picture, right? You can see the order of entropy. हर एक substance का gas is more than liquid is more than solid, है ना? Right. That's it. Very important things we are discussing. Abhinav, are you there? Right? Abhinav beta and Annamani and Ishita, fine. Hope you understand this. Now the difference between the enthalpy and entropy. So this is your enthalpy and this is your entropy. So enthalpy is denoted by H. Enthalpy is denoted by H and refers to the measure of total heat content in the thermodynamic system under constant pressure. That is enthalpy. Then entropy is the denoted by S and refers to the measure of level of disorderness of thermodynamic system. When the water is taken in the ice cube and the molecules are organized and it is converted into a liquid, the molecules are disorganized. यही है. हर्षित मिश्रा हाँ बहुत फास्ट पढ़ाता है, क्योंकि स्लो पढ़ाना है क्या, टाइम बहुत कम है ना बेटा. सो अभी फ़िलहाल आधा क्लास ये रिवीजन का है. सो एस्टरडे एंड कल परसों भी ख़त्म कर लिया एंड आज थोड़ा सा रिव्यू करना चाहता हूँ, इसीलिए इतना ज़ोर से पढ़ा रहा हूँ आपके लिए. हर्षित मिश्रा कोई प्रॉब्लम नहीं, सिर्फ आपके लिए थोड़ा सा देर में करना हो सकता है ना, हो सकता है, हाँ हो सकता है, राइट. नेक्स्ट एंड द बेसिक चार्ट एंट्रोपी वर्सेस एन एंथैल्पी. सो एंट्रोपी मान लो these are the properties and enthalpy and these are the properties. So what is exact meaning of entropy? It is a measurement of randomness, है ना. Enthalpy, it is a measurement of heat at a constant temperature, right? And let us see the units. दोनों का units एक ही होता है. So units of measurement, joule Kelvin inverse and joule mole inverse, that is the units of measurement. And what are the requirements? There is no requirements, no limit for entropy. इतना हो सकता है, इतना हो सकता है, इतना हो सकता है, लेकिन एंथैल्पी का कांस्टेंट प्रेशर इज द लिमिट, द टेम्परेचर इज द लिमिट, है ना बेटा. सो द टर्म एंथैल्पी एंड एंट्रोपी you are learning, and how you apply, you need to know their properties, right? That's why Ishita, Arshit, right? Arshit, fine. And formula, entropy is equal to heat upon temperature, whereas enthalpy is equal to delta H is equal to delta U plus delta nRT. And PV is equal to nRT, we can say PV, right? Nature, it is a property. It's a property of the matter. Whereas enthalpy is one type of energy. It is a kind of expressing energy at constant pressure. And abbreviation S and H, and is discovered by Clausius, and this is discovered by Heike. And system favors, always system try to get the minimum entropy and maximum enthalpy, so that minimum enthalpy, minimum energy, so that more stability, and maximum entropy. maximum entropy. System always try to increase its entropy. Universe always for an irreversible process, and the system universe entropy always increases. That is actually what you say, it's the second law of thermodynamics, है ना? Yes. So let's go. Second law of thermodynamics, entropy of universe increases in all spontaneous process. For example, a liquid goes into the vapor state. When you take a liquid in a glass, in a beaker, the liquid always try to evaporate. It all depends upon the nature of liquid as well, but it is going to be evaporated. And entropy change between any two states of a same substance at equilibrium is given as delta S is equal to Q reversible upon temperature. Okay, and also you can say if the process occurs with a change in temperature, then to calculate entropy change, delta S is going to be sum of dq reversible upon time, okay, temperature. So these are the formulas that I am giving you now, is very important. You all make a cheat sheet of it so that you can have either theoretical or logic breaking questions, or maybe a numerical also. You can do it, right? है ना? Yes, आप कर सकते हैं, right? Now let's talk about one more. Absorption of heat by the system leads to the increase in kinetic energy, because kinetic energy of a system is directly proportional to absolute temperature, right? Yes. Now absorption of heat at low temperature develops more disorder than at high temperature, and that's very important. Thermodynamically it is true. So if you take a gas at 25 degrees centigrade, it absorbs a 10 kilojoules of heat. Increase in entropy is more as compared to the gas at 100 degrees centigrade takes the 10 kilojoules of heat. So at low temperature में entropy ज़्यादा बढ़ते हैं. That's very important beta, very important, है ना? Okay, so you can see that is the reason why. So absorption of entropy and the temperature. So you can see at its melting point and its boiling point, there is, you can see, increase as temperature changes, entropy increases. Temperature increases, entropy increases. Temperature increases, entropy increases. When you see at its melting point, entropy sharply बढ़ रहे हैं. At its boiling point में भी entropy sharply बढ़ रहे हैं. So that is important. That is very important point. So based on that, in the NEET examination, or any kind of competitive examination, statement based questions will be there. Statement based questions will be there. So always you think that अरे thermodynamics सिर्फ न्यूमेरिकली करने हैं. अरे thermodynamics न्यूमेरिकल कर सकते हैं. फिजिकल केमिस्ट्री में अगर थियरी ओरिएंटेड क्वेश्चंस काम है तो it is very easy and logical, so those who has a very good hold on the subject can answer it. So ये ऐसा आपको मैं ट्रेनिंग दे रहा हूँ नीट एग्जामिनेशन में. स्टेटमेंट बेस्ड क्वेश्चंस कहाँ से निकलेगा, कैसे निकलेगा, है ना? कर सकते हैं, आप करना है. तैयार है? एक थम्स अप एंड फायर इमोजी डालो क्लास में जल्दी. मेक इट फास्ट. हर्षित मिश्रा, hope you are able to understand. Great. Abhinav, or Logamanagam, Shivans and Spencers. I can see many students who are actually regularly present in the class. Okay, excellent. Okay, let's talk about second law of thermodynamics में the units of entropy. मैं अभी बोल चुका हूँ जूल केल्विन इनवर्स. एक्चुअली दी एंट्रोपी का जो वैल्यू आता है ना, छोटा सा 3 joules 10 joules ऐसे आते रहते हैं. व्हेन यू टॉक अबाउट द एंथैल्पी ना, 300 kilojoules 20 kilojoules like that, they are high values, they are small values मान लो. and the units are molar entropy or joule mole inverse Kelvin inverse. so ये एंट्रोपी का यूनिट है, ये मोलर एंट्रोपी का यूनिट है ना? यस. नाउ और एक चीज है, फॉर ए स्पॉन्टेनियस प्रोसेस डेल्टा एस हमेशा पॉजिटिव होना है, so it is going to be greater than 0. It is for a spontaneous process. ये spontaneous process क्या? So ये जो process खुद ही जाने का कोशिश करता है, खुद ही perform करने का कोशिश करता है. When you take an ice and put it on the table at room temperature, you need not have to ask the ice to melt, it melt itself na. That is called spontaneous process. And for a non spontaneous process आगे ना बढ़ते हैं, process delta S is less than 0, ये negative है, right dear students? Okay, so let's talk about at equilibrium delta S फिर 0 है, so where delta S is equal to delta S system plus delta S surroundings. But for an isolated system, delta S total is equal to delta S system, क्योंकि isolated system में आपका surroundings नहीं कर मुलाकात करते हैं, so that system खुद ही universe बोलना है ना? Yes, it is. It's very important parameter, that is, and entropy change and the reversibility of a process. So many things from here we are going ahead. आगे बढ़ने तो तैयार है अब? Yes, it is. Let's talk about entropy change and reversibility of a process. So आहिस्ता आहिस्ता entropy करने के बाद आप thermochemistry में जाना है, तैयार है, so that delta S system is equal to minus delta S surrounding, क्योंकि ये system है and this is your surroundings. When the system loses its entropy, so इसका negative होगा, इसका positive होगा. अगर ये system absorbs entropy, इसका negative होगा, इसका positive होगा. That is the way it is say that delta S system plus surrounding is going to be 0. This is the condition. Okay, so there is no change. You can't create it, you can't destroy it. So सब मिलने के बाद 0 ही होना. And second law of thermodynamics, in an isothermal reversible expansion of a gas, work done in irreversible will be less than work done in the reversible. Okay, so this is isothermal reversible expansion, because system is doing work done by the system. And talking about heat, Q irreversible also be less than the Q reversible, and these are the various parameters you need to know, right dear students? Now what I mean to say, this is indicating entropy change of the system is equal to Q reversible by time, and entropy change in the surroundings is going to minus Q irreversible time, so that ये दोनों मिलके delta S system plus delta S surroundings should be greater than 0. I want to say this is what you call it as second law of thermodynamics. So system plus surroundings total, you can say it is delta S total. I just want to say entropy of the universe greater than 0, mean to say ये हमेशा increase करने का कोशिश करता है ना? Yes, it is. Now let's talk about, this is a spontaneous process, criteria of spontaneity. So a spontaneous process है क्या? आप बोलो, और अभिनव है ना? Okay, so when a stone is rolling down, so nobody is doing work on it, it is coming by itself, right? Spontaneous direction is a downhill process unaided. So system has a self urge to proceed by itself. That is process. That process is called spontaneous process. So let us talk about a process which may take place by itself after a proper initiation, or may not be initiation. Some processes require initiation, some process may not require initiation. Okay, so let's talk about a spontaneous process may takes place instantaneously or very slow. What is the meaning of instantaneously? अचानक शुरू होता है. When the bomb is blasted, it's an instantaneous reaction, है ना? And rusting of iron is a slow process, but it is a spontaneous process, right? So sometimes it can be instantaneously or sometimes it could be slowly. Understand? And now non-spontaneous process, the process which cannot take place on its own, not feasible at all, that is called non-spontaneous process. And flow of water uphill and flow of heat from a colder body to hotter body, diffusion of gases from low pressure to high pressure, and dissolution of sand in the water. So sand do not dissolve in the water, right? So you can see this is your spontaneous process, the rolling stone from down the hill. And if you want to go for a stone from the up the hill, it is a non-spontaneous process. समझ में आ रही क्या? So the rolling of a rock uphill is a non-spontaneous process. The rolling of a rock down is a spontaneous process. The rock eventually comes to the ground and attains the equilibrium. So जब यहाँ पे पहुँच गए ना, equilibrium between these two can be acquired, है ना? So कब तक spontaneous हो सकते हैं? जब ये system equilibrium मिलेगा ना, तब तक, है ना? That's very good, very good. And let's talk about here when the gas is taken into the vacuum, when this tap is released, the gas molecule forces into these so that there is an equilibrium between these two. So this direction the process is spontaneous, and in this direction the process is going to be non-spontaneous. समझ में आ रहा है क्या? Right. So you have so many experimental examples there. We can see a process कब spontaneous होता है, कब non-spontaneous होता है, spontaneity का criteria क्या है? So that it is called criteria of spontaneity. Spontaneity mainly develops in two processes, right, Ishita? So what are the processes? You can see tendency to attain minimum energy, so that a system at high energy unstable होता है, a low energy पहुंचने के लिए कोशिश करते हैं, so that it is supposed to be exothermic process. Yes, हर exothermic process spontaneous होता है? नहीं, melting of ice is endothermic process, तभी ये spontaneous है. कैसे? And second one, a tendency to maximum randomness, tendency to attain a minimum energy, ऐसे process का है, delta H is going to be negative. Tendency to get maximum randomness, delta S is going to be positive. So these two parameters simultaneously take into the action to talk about this spontaneity, criteria of spontaneity. मान लो इस बहुत important चीज़ है, and mainly exothermic reactions is believed, पक्का नहीं होगा, believe it to occur readily and spontaneously, right? है ना? And some endothermic reactions are also found to be spontaneous, like melting of ice. So that ये पहला जो point दिया ना, ये contradict कर रहे हैं ना, contradict है. Now criteria of spontaneity. So criteria of spontaneity: tendency to get minimum energy, tendency for maximum randomness, and also a result of these two above tendencies gives the overall tendency for the process to occur is called the driving force for the process, and the driving force is called Gibbs free energy. So Ishita, ये Gibbs free energy है क्या? Gibbs free energy. Now you are going to introduce Gibbs free energy. Get ready. Get ready. Yes, that's good. So Gibbs free energy change. Gibbs free energy, it is a measure of the capacity to do useful work. That is the point. So, the decrease in the value of Gibbs free energy is equal to the maximum possible useful work. So, actually, when a system want to stabilize from high energy to low energy, it decreases its energy, so that the energy is coming out. That energy is coming out should be doing some work out of it. So, इसमें कितना एनर्जी आपका वर्क डन के लिए फ़ायदा उठ रहा है, दैट इज़ यूजफुल वर्क, दैट क्वांटिटी इज कॉल्ड गिब्स फ्री एनर्जी. And when the system is doing work, it has to pay some tax by increasing in entropy. That is what the relation between entropy and the heat and the useful work, that is given by the Gibbs free energy, that is G is equal to H minus T delta S, है ना. And this is what you call it as G system is equal to H system minus T delta S system. In the isothermal change, delta S system, delta G system is equal to delta S system minus T delta S system, or you can also say delta G is equal to delta H minus T delta S, and this is just like a super law. This is called Gibbs-Helmholtz equation. This is, you call it as Gibbs-Helmholtz equation. Gibbs-Helmholtz equation, delta G is change in the Gibbs free energy, and delta H, that is change in enthalpy, and T temperature, and delta S change in entropy, Joule Kelvin inverse, and change in enthalpy kilojoule per mole, and it is given in the kilojoule per mole. And for a process to be spontaneous, delta G should be negative, and for a non-spontaneous process, delta G should be positive. At delta G is going to be 0 for equilibrium process. That's good, that's good, very good, nice. Now let's see the details of this. Effect of temperature on spontaneity of a reaction. यहाँ पर मैं कुछ लिख देता हूँ. So delta G, here delta G is negative, the process is going to be spontaneous, and delta G is going to be positive, that is going to be non-spontaneous, and delta G is equal to 0, the system is said to be at equilibrium. It is very simple, मान लो, and you can use this in organic chemistry, other parts of the physical chemistry as well, है ना? Right. It is. Ishita, where are you? Not responding. Okay, you are busy on writing the notes. I know that you definitely write the notes by following every day's class. Let's see effect of temperature on spontaneity of the reaction. So इसमें मान लो यहाँ पर delta G is equal to delta H minus T delta S. Okay. So मान लो a process का negative delta H is going to be negative and delta S is positive. Okay. So that delta G आपका आएगा negative at any temperature value. At any temperature value. So I want to say spontaneous at all temperatures. है ना? Now if delta H is negative and delta S is negative and delta G is going to be negative, which means that spontaneous सिर्फ only at low temperatures. This table can give you algorithm for cracking so many questions in NEET examinations. My dear students, follow here. If delta H is negative, so that negative, it is called exothermic process का है. Exothermic process का है. Delta S is negative and delta G can be positive, दोनों का वजह से non-spontaneous at a high temperature का condition में, or delta H is positive and a positive, that is called endothermic process, so that delta H is positive and delta S is positive and delta G is going to be negative, so that spontaneous at high temperature, and delta H is positive, delta S is negative, delta G is going to be positive, that gives non-spontaneous at all temperature. यहाँ पे spontaneous कब कब होगा? spontaneous 3 spontaneous combinations, 2 non-spontaneous combinations आता है ना बेटा? Clear? Any doubt? So this particular table is very very important for Gibbs free energy change का, कर लो जल्दी, कर लो एक बार, एक स्नैपशॉट ले लो, 3, 2, 1. Now let us go ahead. So criteria of spontaneity: delta S total is equal to delta S system plus surroundings, and if the heat QP is lost by the surroundings and gained by the system, then surrounding का minus आता है, and फिर भी where T is the temperature of the temperature at which heat change occurs, so that QP is equal to delta H of the system, and in the criteria of spontaneity, therefore delta S surroundings is equal to minus enthalpy change of the system at upon temperature, and substituting the equation 3 in equation 1, so that you are going to get delta S total is equal to delta L system minus delta H system. So these are all the collection of formulas that you need to know, collection of formulas, right? So make a cheat sheet of this collection of formulas and you can do the best, right? That's good, nice to see, good number of students, and I just want to see the active participant in the chat box also. Okay, now let's see, multiplying equation number 4 with the temperature, so that T delta S is equal to T delta S minus H system, enthalpy of a system, so that Gibbs free energy of the system is equal to minus T delta S of the total, है ना? Very good. Now let's talk about, if delta S is total is a positive, delta G system is negative, the process is spontaneous, the पहला condition है, and if the delta S total is negative, delta J system is a positive, the process is non-spontaneous, my dear students. And you can also say these are the various conditions delta S total का वजह से, अगर delta S total is 0, delta G system is 0, तभी ये system equilibrium होगा, right? And now you can say, who is going to give the answer for this question? At equilibrium, x plus y reversibly gives rise z, and heat is positive here and the spontaneous in the forward direction. So then the corresponding sign delta G and delta S should be. Can you just give me which option is correct? Ishita and other students, come on. Other students, come on. Yes, delta G is equal to delta H minus T delta S. In order to say a process to be spontaneous, delta H is supposed to be negative and delta S supposed to be positive. That is your answer. So my answer is going to be negative and positive. है ना? Clear? Fine. Now, although the dissociation of ammonium chloride in water is an endothermic reaction, so that delta H is going to be positive, and it's spontaneous because इसका delta G negative होना है. So delta H is positive and S is positive and delta H is less than T delta S. Fine, it's very good, it's very good. Now for the process, H2O solid gives rise H2O liquid. That's D, correct. So at 273 Kelvin, 1 atmospheric pressure, which of the following is true? Could you guess it? Could you guess it? Could you guess it? Very good. Now this is going to be change in the delta G ice minus change in delta G water is not equal to 0. So that is going to be the option 1. So delta G ice and delta G water. So this is an equilibrium. So 1 atmosphere 273 0 degree centigrade है ना, 0 degree centigrade में ये equilibrium में आना, जब equilibrium है ना, it is going to be 0, right? Very good. Now let's start. The law determines the value of entropy of a system at temperature K, and the entropy of perfectly crystalline substance is 0 at absolute 0 temperature. This is what you call it as the third law of temperature. At absolute 0, the entropy of a perfect crystal is going to be 0. So kinetic energy is going to be directly proportional to temperature. When you take this value is 0, if T is equal to 0, kinetic energy is going to be 0. जब kinetic energy 0 है ना, its entropy is going to be 0. That's it. So this is mathematically explained by ST integral of NCP from 0 to T and of dt by T. So this is what you call mathematical version of the third law of thermodynamics. It's very simple. Only one entropy of the perfect crystal at 0 Kelvin is absolute, 0 is 0. That's it. And it is going to be, so it's a perfect crystalline solid. है ना? Kinetic energy is 0. है ना? Right. Now let's talk about thermochemical equation. What is thermochemical equation? Somebody please confirm. Now, so the thermochemical equation should be a balanced chemical equation, and delta H of the reaction should be mentioned here, and gives a physical state of reactants and the products. So the physical state or allotropic state has to be mentioned, and everything is mentioned is called thermochemical equation. So thermochemical equations can be seen like negative is shown exothermic, positive is shown endothermic. So heat of a reaction, yes Ishita, heat of a reaction, this is also called as enthalpy change of a reaction. So the heat lost or gained when all reactants are converted into products shown by the chemical reaction is called enthalpy of a reaction. So when a reaction goes, so enthalpy of reaction is equal to sum of the enthalpies of the products minus sum of the enthalpy of a reactants. So we know that delta H is equal to delta U plus delta nRT, where delta N is equal to product minus reactants in the gaseous state. Yes, it is. Now that enthalpy change, enthalpy of reaction, ये reaction के जैसे, ये reaction can be a combustion reaction, can be a neutralization reaction, can be a formation reaction, can be a type of reaction. We are going to see the various forms of the enthalpy changes. Let's talk about exothermic reaction and endothermic reaction. Exothermic reaction is a reaction where heat is released, so that in the exothermic reaction enthalpy of the reactants is greater than enthalpy of the products. So here that is mentioned here, and for exothermic reaction delta H is going to be negative. So heat lost by the system. Okay, that's good, nice response. And endothermic reaction, the reaction in which the heat is absorbed, delta H is going to be positive, and here enthalpy of the products is greater than enthalpy of the reactants, so that heat should be absorbed. Okay, that's good. Now enthalpy change at standard conditions, So the heat change at 298 Kelvin or 25 degrees centigrade at 1 atm, if you measure, that is what you call it as enthalpy of the reaction. Delta H naught is mentioned. So at standard conditions, enthalpy of the reactions we have to change, and the enthalpy of the reactions are given as standard enthalpy change of reaction depends on these are the 6 conditions. So I mean to say, in the NEET examinations, my dear students, from which of the following the standard enthalpy change is dependent or not dependent, kind of theory oriented questions will be there. So enthalpy change is dependent on these 6 factors: heat capacity, temperature, physical state, concentration of solutions, pressure and volume, and stoichiometry in the direction of reaction as well. So let's talk about the amount of heat evolved or absorbed when 1 mole of a compound is formed from its element is called enthalpy of formation. That's very, very important. So it should be from elemental state. The reactant should be in the elemental state. I want to say carbon in the graphite plus oxygen gives rise carbon dioxide in the gaseous state. This reaction indicates enthalpy of formation of carbon dioxide. You want to say calcium carbonate on heating gives rise calcium oxide plus carbon dioxide in the gaseous state, and this reaction do not indicate enthalpy of formation of carbon dioxide. Fine. So it should be from elemental state, a standard enthalpy of formation. Understand? Clear? Now it is a standard states, it's called standard enthalpy of formation. Enthalpy of formation may be positive or negative, and formation of ammonia. So N of N2 plus 3 by 2 H2 gas gives us 1 mole of this only. So 1 mole of ammonia form करने के लिए minus 46.35 Kelvin heat निकल रहा है. So this is called enthalpy of formation of ammonia, and you don't memorize these values. This is enthalpy of formation of sulfur dioxide. In that standard state, sulfur rhombic allotropic लेना है, carbon graphite allotropic लेना है. Now if it's formation of nitric oxide, it is given like this. Studying the chemical equation, thermochemical equation is very, very important. Okay. Now standard states of some example. So enthalpy of formation of a standard elemental state is always equal to 0. That's very important. So for graphite, enthalpy of formation is 0. Sulfur rhombic, enthalpy of formation is 0. Bromine as a liquid, enthalpy of formation is 0. Iodine solid, enthalpy of formation is 0. Chlorine gas, nitrogen gas, hydrogen gas, oxygen gas, enthalpy of formation is always 0. मान लो ये graphite का rhombic का, and phosphorus, white phosphorus is taken, exception, red phosphorus is more stable than white phosphorus, but standard state white phosphorus leta. Okay. So like this you can say, it's very, very important. When you calculate thermochemical equations, it is important to use these standard values as 0, otherwise you can't solve the entire equation. Okay. So consider the following thermochemical equations at 25 degrees centigrade or 1 atm, and it represents the formation of HCl at standard condition. So enthalpy of formation is given in the reaction. So from the definition, enthalpy of reaction is equal to sum of the enthalpies of products minus sum of the enthalpies of reactants, and it is given as molar enthalpies, and according to the stoichiometry we need to do it, so that when you take these values, जितना भी heat आ रहे हैं उसमें उतना ही enthalpy of formation आना है. That's very, very important. Ishita, fine? Ishita, is that fine? Get ready. Tomorrow we are going to discuss about total thermodynamics. Yes, total thermodynamics multiple choice questions. Are you ready for that? Ready? Yes. Now, enthalpy of formation. In that, enthalpy of formation is heat of a reaction divided by number of moles of the product. Heat of the reaction upon number of moles of the product. And also, a standard enthalpies of element delta H naught is assumed to be 0, I said no. So, the standard enthalpy of compound delta H is equal to the heat of formation. That is also one more trick to say that. You know, that's good, very good. So, now let's talk about enthalpy of combustion. So, combustion is always exothermic reaction when 1 mole of heat, 1 mole of substance is completely combusted in the presence of oxygen. The heat released is called enthalpy of combustion. Yeah, anyone need study materials, free infinity learn materials, doc. So, the entire session material you are going to get in the PDF form in the Telegram channel. Everybody please log into the Telegram channel, and Google form link is also given in the chat box and the description box. You can click it and you will get it. Download everything. Fine. Doc Anup. Anup. Oh, okay. Right, Ishita. Now let's talk about the calorific value. This is very, very important. Enthalpy of combustion upon its molecular mass. So, the calorific value of the substance is calculated by using this formula. So, calorific value, Kuldeep Rajput, hello, Kuldeep, how are you beta? How are you beta, Kuldeep? Okay, let's go ahead with this. So, calorific value you can do by using a calorimetry. We are also going to do that. Okay, so enthalpy of combustion. Higher is the calorific value, more efficient is the fuel. Heat of combustion of ethanol is minus 1367 and it is minus 1367 heat of combustion. इसका calorific value carbon कितना होगा? minus 110. So who is the better fuel? Who is the better fuel? Make it fast. Who is better fuel? So this value is divided by molecular weight. So that if this value is divided by molecular weight, this value is divided by molecular weight. So the one which gives the highest value is going to be the super calorific value. Yes, super calorific value fuel, right? So this is your BAMB calorimeter. So in this BAMB calorimeter, Q is equal to ms delta T. Q is equal to ms delta T. So you can measure the heat of the substance. It is completely combusted. How much heat is released is measured by using T1 minus T2 by delta T, and S is the specific heat capacity of the calorimeter, and M is the mass of the substance, and Q is the heat. Okay, from this you can calculate the calorific values or enthalpy of combustion, many things, right? And that is the working done by the heat of combustion. Delta E is equal to minus Z into theta into M by M. So what is theta? It is the rise in the temperature, that is delta T, and Z is the heat capacity of the calorimeter, and the mass of the combustible substance M, and capital M is the molar mass of the combustible substance. So you can also use this particular formula in the calorimetry, in the enthalpy of combustion, right? Ready? Now enthalpy of combustion, some more measurement of delta H you can do. Q is equal to MCT, that's what MST you can use, MCT you can use, and this can be done by using simple coffee cup calorimeter or bomb calorimeter, right? Now it is going to be heat enthalpy of solution. It's very important in the NEET examination. Enthalpy of solution, when a solute is dissolved to make a saturated solution, So heat liberated or absorbed when 1 mole of substance is dissolved in large excess of water, heat of the solution may be negative or positive. So Raoult law you don't use here, right? It can be positive or it can be negative. So magnesium sulfate, when you dissolve solid in the water, you are going to get magnesium sulfate aqueous, delta H is going to be minus 84.42. Okay, sometimes ammonium chloride, when it is dissolved, it is going to be, it could be negative or positive. Array, enthalpy of hydration is different, enthalpy of solution is different. So solid to aqueous, this is a solution. When it is talk about the gases to aqueous, that is called hydration minded. That is only the difference between these two, right? HCl in the water, delta H is going to be minus 75.2. So these are the examples for the heat of the solution. Okay. Now integral heat of solution, that's very important. So HCl is a gas. When the water molecule is hydrated, it is going to get HCl decahydrate. This is what you call it heat, integral heat of solution. We are not getting into the aqueous solution, we are getting the hydrated part of the molecule. So like 40 H2O, this is 40. So it is going to be integral heat of solution. The heat liberated or absorbed when 1 mole of solute is dissolved in fixed volume of pure solvent to prepare a solution of specific concentration is called integral heat of solution. Okay, and here it is enthalpy of solution of HCl in water is minus 75.2 and the integral enthalpy of solution of 10 moles of water is minus 69.5 and the difference. So the enthalpy of dilution of HCl in 10 moles of water to 40 moles of water is going to be, the difference it is going to be 3.6. So it is very simple. So we are going discussion in that level so that you can do the best. You know? So how much quantity of the content is being delivered in these 90 minutes of session, my dear students. So you need to be so perfect in this. Okay, let us talk about Hess law. Okay, bond energy. So after bond energy, we are going to discuss about Hess law. Okay, there we are going to end up the session. Right, next 10 minutes we are in the fire. So in the gaseous diatomic molecule, the enthalpy change involved in dissociation of 1 mole of covalent bond to produce a gaseous atoms is called bond dissociation enthalpy. So when the bond dissociation, so association dissociation magnitude same hota hai. So H2 is broken to get hydrogen atoms. So amount the enthalpy change during 1 mole of a bond of a type is broken into its gaseous atoms. Yes, Ganesh. Real type of example you can see, my dear students, sodium hydroxide when dissolved in the water, water is going to be hot. When ammonium chloride dissolved in this solution, you are going to get a cold sensation. So if it is a salt, when you are weak, you dissolve glucose in the water and drink na, it become cool na automatically. So heat change is observed. That is a real time example. Hope you understand. Clear? A thumbs up. Okay, so sometimes we need average bond enthalpy. So when you talk about a methane, carbon is with 4 bonds. So bond energy of carbon to hydrogen, okay, is going to be, so you have to break this bond, let's say मान लो X, Y, Z, okay, or otherwise you can say ABC, you can say A, मान लो यहाँ पर A, B, C, D, A, B, C, D, it is going to be A plus B plus C plus D upon 4 because it is average. That's good. that is the average. You can say CH4 एक bond बना काट दिया में plus 42 470 427 and you can say CH3 से और एक है plus 439 CH2 के और एक है plus 452 CH में और एक है plus 347. So the carbon to hydrogen bond energy है ना, you are going to get 427 plus 439 plus 452 plus 347 by 4, that is equal to 416. That is the average, because the every bond in the methane is not same. Once the bond is broken, the other bond is going to change its parameters. So that is what you call the enthalpy of atomization. One more. So the amount of heat required to dissociate 1 mole of pure substance into constituent gaseous atoms is called enthalpy of atomization. So that it is solid or it could be anything. You are going to get gaseous pure atoms. That is called Mahadev. Mahadev, Lord Ganesh, Ganapati Bappa Moria. Okay, that is going to be enthalpy of atomization and enthalpy of hydration. Also, we know it. Copper sulfate is an anhydrous solid. Taken water to give rise copper sulfate dot pentahydrate, and it is colorless and it is white in color, and it is going to be white in color. It is going to be blue. So hydration is achieved here, so that minus 78.2 is minus 78 to 78.2 is liberated. So enthalpy in the phase transition, solid to gas sublimation, solid to gas sublimation is seen. Enthalpy of allotropic forms, sulfur rhombic to sulfur monoclinic, the change is given. So the same enthalpy of reaction but different processes we need to discuss, right? Enthalpy of sublimation, enthalpy of fusion plus enthalpy of evaporation. Why? Because I am fine. Thank you, Mahadev. So we are coming to the end of the session. Just say hi, bye, nahi, just fire emoji and thumbs up. So the amount of heat required to convert 1 mole of a solid directly into the gas is called as enthalpy of sublimation. Okay, so like that you have enthalpy of ionization of the aqueous solutions. The same way you can say, right? That's good. And talking about the last point, that is Hess law of constant heat of summation. So it says that the heat of the reaction, okay Mahadev, you just take care because of this seasonal, you just take care of it, take medicine and study and watch the recordings, the previous one. Hess law of constant heat of summation says enthalpy of reaction is always constant whether the reaction directly takes place in a single step or in multiple steps. He want to say here delta H is in a single step में बदल रहे हैं ना, एक step 1 में delta H1 बन गया, step 2 में delta H2 बन गया, step 3 में delta H3 बन गया. So the heat of a reaction is same whether the reaction takes place in a single step or in the multiple steps. So based on that you can have the Born-Haber cycle, you can calculate enthalpy of various parameters logical way. So this today's session we had a great discussion about first law of thermodynamics, enthalpy and entropy, second law of thermodynamics, third law of thermodynamics, total thermochemistry. Yes, you all enjoyed, and get ready. Tomorrow we are going to discuss about all multiple choice questions based on your thermodynamics, and also we will explore some more questions from the thermochemistry. You all fine? Say bye. Thank you. Please like and share and subscribe the sessions. Thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity Land Studio. Bye bye.